Hello everybody and welcome to Algo Expert. In this video, I'll be covering the question of minimum waiting time. Now before we dive in, let's make sure we understand what the question's asking of us and the input and output structure. So for this question, we're going to be given an input array containing positive integers that will always have at least one value inside of it. Now all of the values or the positive integers in this array will represent the duration of a query that needs to be executed. So we can execute these queries in any order that we like, but we can only execute one query at a time. And what we are trying to do is minimize the amount of total waiting time for all of the queries such that they are executed as fast as possible. So we need to pick the order in which we execute these queries such that the total waiting time for all of these queries will be minimal. Now, what is a waiting time of a query? Well, that's what we need to explain next. So if we're having a look at this input array right here, let's just say that we decide to execute the queries in the following order. So we execute the query with duration 6, then the query with duration 1, then both of the queries with duration 2, and then finally the query with duration 3. Well, the amount of waiting time is how long a query must wait until it starts executing. So if this is our first query, and actually I'm just going to label with some numbers down here the execution order, so 1, 2, 3, 4, and 5, our first query needs to wait a total of 0 seconds or 0 units of time before it's executed because it is the first thing to be executed. And our second query will need to wait a total of 6 seconds before it can start executing because that is the duration of the first query. So we say that query 2 takes 6 seconds, or sorry, has a waiting time of 6 seconds. Now query 3, well, query 3 has to wait for both query 1 and query 2 to finish executing before it can start. So that means that query 2 is going to have a total waiting time of 6 plus 1, which is equal to 7. Now I'm just writing 6 plus 1 out here just so you see that it's based on the first two queries duration, how long this query takes to execute. Now, if we have a look at query 4 here, well, this needs to wait for query 1, for query 2, and for query 3. So we simply sum up all of their durations, and we see that the total waiting time for this query is going to be 9. Then our last query right here, well, this needs to wait for all 4 of the queries before it to execute before it can start. So we see that we get a total waiting time of 11 for this query. So now that we know the amount of waiting time for each individual query, we need to sum all of those together to determine the total waiting time based on this execution order. So we can do that, and we see that we get 11 plus 9, which is equal to 20, and then we have 6 plus 7, which is equal to 13, and that gives us a total waiting time of 33. So obviously this is not the minimum waiting time, and this is not the correct order in which we should execute these queries, because as we can see in the top right hand corner here, the minimum waiting time for this problem is actually 17. So this is kind of how this problem works. We need to figure out the optimal order in which we should execute these queries such that we will have the minimum waiting time. Now for this problem, we do not need to return the order in which we execute these queries. We just need to return the minimum waiting time. But to be able to find that, we do in turn need to find the order or figure out somehow what that minimum waiting time actually is going to be. So hopefully that explains it. But as you move around different queries here in the execution order, you're going to see that you get a much different answer based on where these different queries are. So now before we dive into the solution, let's quickly cover a few more important details for this problem. So first of all, as I stated, we are only going to be given positive integers in our input array. So we don't need to deal with floating or decimal point values, and we don't need to deal with the value 0 or any negative values in our input array. That's important to understand, and you would definitely want to ask that question in a coding interview if that was not directly stated. Another thing that's important is that the minimum length of the amount of queries we're going to be given is 1. So we will always be given at least one query. That's important because if we were given no queries, then that might be an edge case that we would have to consider in our solution. Now let's quickly just go through what happens when we're actually given a list or given an array that only has one query. So let's say we're given this as our input. So an array that has the query with value 100. The total waiting time for any input that is simply one query is always going to be 0. The reason for that is we're talking about the amount of time it takes until a query starts executing. So some people may have thought that this would be 100 as the total waiting time, but that is not true because this query gets to start executing immediately. But now if we had one more element in this array, so if we had 100 and then we had 1, our total waiting time would be 100 because the first query takes 0 time to start executing, but the second query must wait the duration of the first query before it can start. So the total waiting time for an input like this would be 100. But hopefully that makes sense. Whenever you're given an array that just has one query in it, the total waiting time will always be 0. So one last detail I'll share before we actually get into the explanation and the solution for this problem is that you can mutate the input array. So you are allowed to change the order in which the elements occur in the input array. You also could completely remove the elements. You could add other ones to it, but that's totally fine. You are allowed to mutate it, and that will change the way in which you implement the solution to this problem. So make sure you keep that in mind. So now as we start thinking about the solution for this problem, the first thing that we should do is really consider how the order in which we execute these queries affects the total waiting time. So as we saw in the previous example, when we executed the query with duration 6 first, we ended up with a total time of 33, which is obviously much larger than the answer to this problem, which is actually 17. So intuitively, it probably doesn't make sense to execute the query that is largest first. And in fact, to illustrate this, I want to look at an example where we only have 2 queries. So let's say we're looking at an example where we have a query of duration 6 and a query of duration 1. Well, if we execute them in this order, so we execute query with duration 6, then query with duration 1, we see that the first query has a total waiting time of 0, and the second has a waiting time of 6. So we add those together, and that gives us the total waiting time for this order of 6. But now, what happens if we execute them in the other order? Well, this is pretty straightforward, but if we execute 1 and then 6, we see this has a total waiting time of 0, and this only has a total waiting time of 1. So we add that together, and we get 1. So that should tell us immediately that it probably doesn't make sense to execute the largest query first, because if we do that, all queries after that will have to wait at minimum the duration of the largest query. And obviously that is not ideal, and that's not going to lead to an optimal solution. So when we're looking at an example like this here, if we execute in the order of 1, 6, that gives us a total time of 1, which is the answer to this problem. That would be the minimum waiting time. But if we execute query 6 first, then that leads to a total time of 6, which obviously is not the correct answer for this problem. So now that we understand that, we can actually have a look at the example I have on my screen at the very top and see what the optimal order to execute these queries in should be. Well, just going based off our intuition and what we looked at before, we're going to start executing the smallest queries first and just see where that leads us. So if I decide that I want to execute these queries in the following order, we're going to execute, say, 1, then 2, then 2, then 3, and then 6. So pretty much the sorted order of this input array here. Then what we'll see is that our first query will take a total time of 0. Our second query will take a total time of 1. Our third query will take the length of both of these, so that's going to be 3. So we can say 1 plus 2. Our third query will take the time of all of these, so that's going to be 1 plus 2 plus 2. And then our last query will take the total time of all 4 before it, so 1 plus 2 plus 2 plus 3. So if we sum this up, we get 0, 1, 3, 5, and then this is 8, and that gives us a total time of 17. So we can see that actually is the correct answer for this example. Now, the way that we got this and the way that this works is that executing the shortest query first is actually just the answer to this problem. That is what we need to do to come up with the optimal time. And the reason this works is because if you think about it, by putting the shortest query first, you're making sure that all queries after it are waiting the minimum amount of time. And that's kind of the idea behind this problem, is that we need to figure out that executing the shortest query first is what will lead to the minimum waiting time, because all queries after it, again, will wait the minimum amount of time before they're executed. Now, let's just see what happens if we change this execution order very slightly, and we actually put 3 before one of the 2's here. So we say 3, and then we say 2. Now, when we do this, that's going to change pretty much all our numbers afterwards, so I'll just erase all of these and rewrite them out, but I want to show you what actually happens here. So the waiting time for query 3 will stay the same, but when we go over to the next query, now we're waiting 3 plus 2 plus 1, or 1 plus 2 plus 3, so a total of 6 seconds. And our last query is now waiting 6 plus 2, or 1 plus 2 plus 3 plus 2, which is going to be equal to a total time of 8. Now, when we look at our answer, what we see is that we get a total time of 18. So even making that one change and swapping the 3 before the 2 did increase our total waiting time, because now there's 2 queries that are having to wait an additional 3 seconds rather than just 1. So you want to place the queries with the shortest duration first, for the reason that the largest queries are going to be at the very end. Because now we see that this largest query being at the very end means that no queries are needing to wait for this to start executing, or to finish executing, sorry. So that means that we pretty much just got rid of the most time-consuming query by placing it at the very end of our list, or of our execution order. So that is actually the answer to this problem, and what we just came up with is what's known as a greedy algorithm. So we pretty much said, let's execute the queries with the shortest duration first, and then we can figure out what the total duration or total waiting time is going to be based on that execution order. Now, the reason this is called a greedy algorithm is because we make a greedy choice at each step. When we're picking the order, every single time we pick the next query to execute, or the first query to execute, we pick the shortest one. And that is a greedy choice. So hence we call this algorithm a greedy algorithm. So this is an approach that you want to keep in mind. This doesn't work for all types of problems, but when it does, it usually leads to a pretty straightforward implementation and a very simple solution in general. You just need to come up with that greedy choice. So now let's just talk a little bit more about the implementation details of this, now that we understand kind of what we actually need to do. So now that we know that we need to execute the shortest queries first, we need to know what the shortest queries are, and well, we need to know what that order is so we can come up with this total time. Well, to do that, what we're going to do is simply start by sorting this input array. Now, since we know that we can mutate the input array, we can sort this array in place, which is actually very nice. It saves us that external space. So our first step in the algorithm is going to be to sort the input array. Then after we do that, all we're going to do is iterate through the input array and just determine how long the total waiting time is actually going to be. So how do we do that? Well, if we sort the input array, then we're going to get something that looks like this: 1, 2, 2, 3, and 6. And now we need to iterate through this order right here and come up with this number 17. So we can start on number 1 right here. And what we can do when we're on number 1 is we can say, okay, well, if this is the first query that we're executing, then all queries after it are going to have to wait 1 second. So we could have some variable over here that we could just say total for right now. We're going to start it equal to 0. And as soon as we hit the first element, we'll say, okay, there's 4 elements left. They all need to wait 1 second. So we're going to say the number of elements left, which is 4, multiplied by the duration of the current query, which is 1. That's going to give us a total time of 4 that all of these queries must wait. And so we'll change our total variable to be equal to 4. Next, we'll move on to the next query. So we'll say, okay, 1 is done. We finish executing that one. Now we're on to 2. So now all of the queries after this one need to wait 2 seconds before they're going to be executed, right? Because this one is happening. So what do? We say, all right, there's 3 queries left. The current duration of this query is 2. So that's 6. And now we add that to our total, and that's going to give us a value of 10. Then we can move on to the next query, and well, we're going to get a very similar thing. So we say, okay, we have this query here. This one's finished. Now, both of these queries need to wait 2 seconds before they can start executing. So we're going to add 2 of these queries multiplied by the time 2. That's going to give us 4. Now we have 14. Next, we'll move our pointer over. We'll iterate over the next one. So this one's done. We're on query with duration 3. There's 1 query left, so what we're going to do is say this query must wait 3 seconds before it can start executing. So we'll add 3 to our total, which brings us to 17. Then this one's done. We move to our last query, but we see that there's none left. So that means there's no queries that need to wait the duration of this query before they start executing. And well, we are finished, and we can return our total of 17. So this is the full solution to this problem. And now quickly, let's just look at the space and time complexity. So this problem is going to run in big O of n log n time, where n is the number of queries or the length of the input array. Now, the reason it's going to run in n log n time is because the first step in our algorithm here is to sort the input array. And we know that the fastest way that we can sort the input array, no matter what method we decide to use, is going to be big O of n log n. Then our next step is to simply iterate through this sorted order and come up with this total. Now that's going to take a total of n time. So we have an n log n step and then a step that takes n time. So really we could write out n log n plus n as our time complexity, but we know that n log n is greater than n, so we can simply reduce this to big O of n log n using big O notation. So that is our time complexity. Now our space complexity, due to the fact that we can mutate this input array and we're going to sort it in place, is actually constant space or big O of 1. The reason it is that is because we don't need to use any extra space for this problem. Yes, we have a variable, but that is as well constant space. So since we're sorting in place, that gives us a constant space complexity. So anyways, that is the solution to this problem. Now let's implement it in Python. So I'm here in my code editor and I have my minimum waiting time function defined, which has one parameter called queries. Now remember, queries is going to be an array which contains positive integers. Now the first thing that we need to do in our algorithm is we need to sort this queries array and we need to sort it in place. So in Python, we can simply use the .sort method and this will sort the array in place in ascending order, which is what we'd like. Next, I'm going to define a variable. I'm going to say total waiting time is equal to, and then 0 like that. This is the variable we use to keep track of the total waiting time as we iterate through this sorted queries array. Next, what we're going to do is say for idx, comma, duration, in, and then enumerate, and we're going to enumerate through the queries array. Remember, this will be sorted after we perform this step because it sorts it in place. And what we're going to do is first determine the number of queries that we have left. So we will iterate through all of the different queries, and at each step we'll determine how many we have left, not including the current query. So for example, when the index is 0, if we had, say, 5 queries, we would say now we have 4 queries left. So to do this, we're going to make a variable. We're going to say queries left is equal to, and that's going to be the length of the queries array, minus, and then in brackets, idx plus 1. The reason we need the plus 1 is because we start indexing at 0. So at index 0, technically we're on the first query. So we need to make sure we account for that by adding 1 to the index. Next, what we're going to do is we're going to multiply the current duration by the number of queries left, and then add that value to our total waiting time. So we'll say total waiting time plus equals, and then this is going to be duration multiplied by queries left like that. Now we're actually finished our algorithm and we can go ahead and return total waiting time. So this is a pretty straightforward implementation. And just as a reminder, this is going to run in big O of n log n time and big O of 1 or constant space. Now n again is the length of the queries array or the number of queries that were given. Now, just to quickly recap what we've done here is we started by sorting the input array. This sorts it in place. This will take n log n time. We then defined a variable called total waiting time, which we're going to add to through every iteration. Then we looped through all of our queries. So we got the index as well as the duration of each query. And we calculated the number of queries left based on the index that we were on. So we said the length of queries minus the index plus 1. That gives us the number of queries left. Lastly, we added the duration multiplied by the number of queries left to our total waiting time. The reason we did that is because every time we see a query, we know that all of the queries after it are going to have to wait that duration. So we go ahead and preemptively add that to the total waiting time. Lastly, we return total waiting time, and that concludes our algorithm. So I hope this was helpful to you, and I look forward to seeing you in another AlgoExpert video.